So thick line is a stretch of the function represented by the thin line, it should say. I don't know where that is. Write an equation for the function represented by the thick line. So the thin line is the original. The thick line is not. Remember, this is just stretches, right, still? So we're not putting in a whole bunch of other stuff. There could be stretches or reflections in this one because that's the lesson is both combined in the textbook, remember? But we're not translating them, which is nice. We will be today after this one, but that's okay. So we're going from the thin line to the thick line. What do you see happening? It's not shifting, right? Because that same top, that max is still the same. Hasn't been shifted to the right or left. I cannot think of what I'm trying to say. Anyways, good times. So it is taller and now it's shorter, right? So what do you think is happening? Vertical stretch. So the easiest way is to compare them from a certain spot. So I'm going to go here. This one is 1, 2, 3, 4, 5, 6 up. The thick one is how many up? 1, 2, 3. So what did we stretch by? 1/2. Because it's half of what it was originally, right? It's half of what it was originally. So we have a vertical stretch by 1/2. So where could we put that? In this case, you're like, oh, I don't know. So you could put it with the y, right? If we put it with the y, what do we put though? 2. So we could go 2y equals 6 over x squared plus 1. Then we could divide by 2. If you like writing it like that, you could. Dividing by 2 is like multiplying by 1/2. So whenever it's a fraction like this, this is a rational, which is a fraction. I always put my division and stuff beside it because then it just makes it easier. Where does it go? Because if not, you're like divided by 2. Do I put it on the bottom? Do I put it on the top? Where do I put it, right? If I write it sideways, then I can just do my math properly. It's 6 over x squared plus 1 times 1/2. So now you know it's actually on the bottom, right? What could we actually write it as? 3 over. What's happening with B? Remember, we're going from thin to thick. Yeah. There's a reflection because the hook was on the top, the hook is on the bottom. What are we reflecting in? You're flipping into the X, but you're also around the Y. It's actually both ways. So if I flip this upside down, the hook would be this way, right? But it's actually, the hook is actually that way. So it's a double reflection. So whoever said X and Y, you're both actually right. Depending on what you saw first. Okay? So we have a reflection in the X and the Y. Is it moved to the left or right at all? This point is here, this point is here. So it hasn't been moved right or left at all, right? But it has been stretched vertically. Has it been stretched horizontally? Remember, compare similar places, okay? So for vertically, I'm going to compare from here, from the lowest to the highest, okay? So lowest to highest originally is 1, 2, 3, 4, 5 vertically. Now it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So went from being 5 vertically to 10 vertically. So how much did I stretch it by? 2. So I know I have a vertical stretch by 2. I know I have a reflection in the X and Y. Now I have to decide, has it actually been stretched horizontally at all? So I could go from this point to this point, right? Like just the hook part. That's 1, 2, 3. And this hook part is 1, 2, 3. Has it been stretched horizontally at all? No. So if we go to write out the equation, the original equation is y equals f of x. So we're technically going to get y equals negative what? The vertical stretch by 2. Negative 2. Because remember when it's on this side, you can just keep it. Negative 2 f of negative x. Remember, if you have a graph that has been transformed already, correct? We always want to start it with the y and then apply it to the whole right-hand side, or start it on the right-hand side, but then put the whole other side in brackets and then make sure you distribute it through, right? If the graph already has some transformations on it. This one was just an f of x, so that's why we could just plop it right onto the right-hand side and not think anything of it. Okay, this one vertically, it looks about the same, right? All that's changed is it looks like it has a horizontal stretch. So we could go from max to min. This one's going to be a hard one. It would be like, like 1, 2, 3, 4, 5, approximately 6. And this one looks like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, oops, 11, approximately 12. If they give you ones on the diploma, they'll make it so it's not like approximately 11 and approximately 12 and approximately 6. But it does look like it's stretched by a factor of 2, right? So where would that 2 go? Trick question. Nowhere. 2 wouldn't go anywhere. What would go in there? 1/2. And where would it go? Attached to the x. And remember, it would replace every x. So this x would come out and it would become a 1/2 x. This x would come out and become a 1/2 x. That x would come out and become a 1/2 x, right? If you're like, I don't like that, you could expand it out and then replace the x's, but either way, it would do the same thing. Okay? I often don't even go over this one because it's so not accurate. Like it's approximately 6. Yeah. Yes. Yeah. Because when we put them back into the equation, it's always the opposite with x's and the same with y's if we put it. Yeah. Okay, so that was just a quick run over of those things. But let's go to what we're doing today. So everything we're doing today you've learned. It's just now we're putting it all together. So it's translations, reflections, stretches. Now you don't have to have every single one. You could possibly have just translations. You could have stretches and translations. You could have a reflection translations, right? Now we can give whatever. So this is a sum up of all the different things. So we're going to go to here. Describe how the graph of the following functions can be obtained from the graph of y equals f of x. Remember, we always have to look at that original function, and in this case, the original function is just f of x. So we have a 1/2 out in front and a -2 at the back. Do we have anything with the x in the brackets? No, so we'll have horizontal nothing, right? There'll be horizontal nothing. If I did mapping, my x would stay the same. It ain't going to change, right? Because there's nothing with the x. So if I go to do mapping, it's going to be x, y, and then it's going to be x. And what am I going to do to my y? Yeah. Yes. We're going to multiply it by 1/2 and we're going to subtract 2 because the y we just do what it is if it's on the right side because it's not with the variable anymore. So it's going to be 1/2 y subtract 2. Some people, it just made a random noise and disconnected. I must have stepped on it. Here we go. Here we go. 2. So we have 1/2 y minus 2. Some people find if you do the mapping, it's easier to say what happened because whatever the mapping is what actually happened, right? So we have a stretch. It's a vertical stretch by a factor of 1/2, because this is what we're doing to the variable, right? We're multiplying it by 1/2 about the x-axis. And it's a reflection in what? There's none. T, translation, 2 down. Vertical translation, 2 down. So does there have to be an S, an R, and a T? No. B, if I did my mapping, I'd have my x, y. What's going to happen to my x? You're going to go to the right 5, so you're going to add 5. Yep, correct. And that's the only thing with the x, right? So that's the only thing that's going to affect my x. Now I have a -3 in front. What's that going to do to my y? Yeah, so we're going to get a vertical stretch of 3 by 3 by a factor of 3. I don't know why I just totally went by a factor of 3 about the x-axis. Do I say ever about -3? No, because the negative doesn't actually stretch anything. It causes a reflection, which is the next one. There's a reflection in the x-axis because it's with the y. And then our translations, you said that already, horizontal translation, 5 right. You try the next one and do the mapping and describe it in the words. I want you to try this one on your own because I want to see if you remember to do what? Take out that -2. So it's going to be y equals 4 f -2 x. 10 divided by -2 is -5. So our mapping is going to be xy becomes negative what x? -1/2 x plus 5, and then 4y. So our stretch, we have a vertical stretch by a factor of 4 about the x-axis. We have a horizontal stretch by a factor of 2. No, a half. About the y-axis. We have a reflection in the y-axis. And we have a horizontal translation, 5 right. So if you're someone who forgot that, if at any point in time you forgot it, star it and remind yourself, because that's going to pop up constantly in all the units. The point M3n is on the curve y equals f of x. Describe how the transformations affect this ordered pair. We're moving a point. What do we do? Mapping. What do we have to remember here? Take out the -1. So y equals 2 f -1 x minus 3 minus 1. So our mapping, our xy, anything in this bracket here affects our x, right? So what are we going to do to our x? Multiply it by -1. And then what are we going to do with the 3? Add it or subtract it? Add it. So we'll do the opposite with our x, except for reflections. You can't do the opposite of a reflection. And then our y, we're going to multiply by 2 and subtract 1. You just do what they are, right? Opposite of x, same as y. So 2y minus 1. We plug in our point they gave us, m and 3n. So for x, I'm going to put in m. For y, I'm going to put in 3n. So I'm going to get negative m plus 3, comma 2 times 3n minus 1. So negative m plus 3, 6n minus 1. The graph of y equals x cubed is stretched vertically by a factor of 3, reflected in the y, so it affects the x, and translated 2 left, 4 up. Write the equation. So, vertically stretched by a factor of 3. Where are we going to put that? Pardon? In front. So we can go y equals 3. Because there's no vertical translation, it's not going to affect it if we put it there, right? It's when there's like more shifts and stuff like that that you have to make sure you apply it. And if you're like, I don't know, start it over here as a third. That's absolutely fine. Then bring it over and make it affect the whole thing. That's okay too, whichever way you want to do it. Reflected in the y means my x is negative. 2 units left means it's actually going to be x what? Why did I put brackets here? Because if that negative was just sitting in front of the x, I would have to take the negative x out, and it would actually change my sign, right? So I always have to have a 1 in front of here, a 1 in front of that x, a positive 1 if I want to put my horizontal translation, right? So the option they may have on your diploma as a multiple choice answer, they might have this distributed in. So I would still always do it like this, then distribute it in. Okay? And then 4 up. Plus 4. This is g of x here. Yeah. Set of y. Good catch. You are right. This next one, we sketch the original, and then we just move points. So we're moving points. What do? Mapping. So we have x squared. So it's 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4. Got it. That's my original, right? If that was drawn actually through the point, which is not done very well. So we're going to sketch the new. So we need our mapping. So our x, y, we check. This is fine because it's all pulled up. So this is actually, this half is what? Is it a horizontal or vertical? Vertical. If it was horizontal, it would be inside another set of brackets here, which it's not. So that's going to affect my y. So I'm going to multiply my y by a half. And then I'm going to subtract 5. Oops, y, subtract 5. And my x, I'm just going to do what to it? Subtract 4, because I'm moving 4 to the left. Then I plug in my points and get my new points, right? That's it. So if I plug in 0, 0, I'm going to get 0 minus 4, 1/2 times 0 minus 5. You see how I said before when we just moved them it was easy, but once I put all the stuff together, mapping is the way to go because it's overwhelming if not. So 0 minus 4 is negative 4, and then this cancels, negative 5. And then we have -1 and +1. So we're going to get -1 minus 4, 1/2 times 1 minus 5. So we're going to get -5. 1/2 times 1 is a half, minus 5. You get common denominator, so it'll be -5 1/2. Then you have to make this over 2. So you times by maybe 2 over 2, so it'll be 10 over 2. So you get -5 and -9 over 5, or 9 over 2, sorry, which is 4.5, which makes sense because if you take -5 and subtract off 0.5, or add 0.5 to it, I guess, you get -4.5. So we're at -5, 1, 2, 3, 4, 5, and -4.5. 1, 2, 3, 4, 5. If you do 1 and 1, you're going to get 1 minus 4, and then 1/2 times 1 minus 5. So you get -3 and -4.5. -2 and 4, you get -2 minus 4, and then 1/2 times 4 minus 5. So you get -6 and 2 minus 5. So you get -6 and -3. And this is symmetrical, so it'll be like this. Ooh, try that one today. Does it make sense? We took a graph, we stretched it by 1/2 vertically. So vertically it's squishing. And when it squishes, it makes it wider. So is it wider? Yes. No reflections, which is good. And it's moved and moved. You guys try B. Don't forget to take the -1 out. And the square root function points are 0, 0 that I use, 0, 0, 1, 1, 4, 2, 9, 3. I don't like using the decimal ones in between. That would be the original function. So we have 0, 0, 1, 1, 1, 4, 2, 5, 6, 7, 8, 9, 3. You can pick the points in between if you really like a challenge and want decimals. Go ahead. I'm not a fan, but whatever. Now we have to remember to take this -1 out. So we're going to get y equals 2 square root -1x plus 3. Because remember, if you forget to take it out, your horizontal translation is going to be the wrong way, which is a problem because that answer will be there, right? So our mapping, our xy, is going to become -x, -1x, minus 3. We do the opposite. And our y is going to be 2y plus 4. We do the same. Plug in our points. So 0, 0. -1 times 0 minus 3. 2 times 0 plus 4. So you're going to get -3 and 4. Which makes sense because the shifts and the reflections don't affect 0, 0, right? Just the translation. Then we have 1, 1. So we get -1 times 1 minus 3. 2 times 1 plus 4. So you get -1 minus 3, 6. So -4 and 6. And then the next one's going to be off this graph. So it's going to look like this. Keep drawing it. So what I'm going to have you do, I'm going to flip you to here. So like I said, this is the homework that's more so like your test once everything's lumped together.